All right, guys, today we are going to start in our notebooks, but then we will be moving to the book on once we finish with this. So first of all, I want to talk about slope. Slope describes the direction and steepness of a line. Typically, we use m as the slope variable. So slope is the same thing as rate of change. It's the same thing as the constant of proportionality. So when we're talking about rate of change, we use the variable k. When we're talking about the constant of proportionality, again, we use k. But with slope, we're going to use m. And that's important that you remember that. So something that Miss Linker does is she thinks of mountains. You know, when you make a mountain, it kind of looks like an M, right? So this is our mountain. I don't know if I spelled mountain right. And we have our little ice tops here. Now, when we are going to the mountains, we ski up the mountain. So here's my little skiing dude. And he's going to go up the slope, on the mountains. And that's why we use, well, it's not why we use M, but it's a good way to help you remember that we use M to describe slope. Okay, I want you to think back to Jack and Jill. Remember, Jack and Jill traveled on this path, and this is starting, so this point right here is Jack and Jill's house. Okay? And remember, because we are starting, we have a constant or proportional relationship here because we are starting at 0 and our line is going up at a constant rate, right? We're passing through that origin of 0, 0. So the equation for this is y equals 4 thirds x, which we found that last time we talked about Jack and Jill. And they are going up at a constant rate. So we have this triangle here. This will form a triangle. This will form a triangle. Now, we're going to talk about Jack and Jill's Aunt Mary, who lives 10 yards from their home, and she's closer to the bus stop. So Monday night, they stay the night at Aunt Mary's house, and they have to leave for the bus stop on Tuesday morning. They walk at the same rate from either of the house, 4 yards every 3 seconds. So for a second, before we get to the graph here, I want to take a second to look at the table. So this is how much time they spent walking, and this is the distance they are from Jack and Jill's house. Now, if they haven't walked at all, oh, and we're not going to do this one right here because it just gets kind of wonky. But if they haven't walked at all, when they were starting at their house, they were still 0 yards from their house. But now, because they're starting at Aunt Mary's house on Tuesday, even though they haven't walked anywhere yet, they're already 10 yards away from their house because her house is 10 yards away from their house. Remember that? Now, if they spend 3 seconds walking, they will have gone 4 yards, and their distance will be 14 because they are 5 yards away from their house plus the 10 yards that put them at their aunt's house. Then we have, if they've walked for 6 seconds, they've gone 8 yards from their house or 18 yards from their Aunt Mary's house. Now look, when we're doing this one, what rate are we still going up each time? We're still going up at a constant rate of 4 each time, just like here, we go up 4, and from here to here, we go up 4. So our rate is not changing at all. Now, let's go back up here and talk about the graph. So they aren't starting at their house anymore. Now they are going to start right here at their aunt's house. I'm just going to put aunt here. They're at their aunt's house 10 yards away, but they are still traveling the same. So if we go back here, when they are 3 seconds away, they are 14 yards from their house. So 3 seconds and we're going to follow this line up to right here. Oops. Okay, and then at 6 seconds, they are 18 yards away. So at 6 seconds, we are 18 yards away. Whoops. So now let's see how badly I can connect these dots. Oh, I actually didn't do that bad. You guys don't have to do this. This is just because my line kind of covered up my points there. So I just kind of made those notches again so we can see those points. Now I want you to look at these two lines. Are they going up at the same rate, or is there one that is steeper or one that is flatter? If we look at it, they're pretty parallel. Remember, parallel means that they're constantly going to be moving next to each other, but they're never going to cross. So that tells us that we have the same rate. The only difference is we are starting 10 yards away from their house at their Aunt Mary's house. So when we go down here and we look at this question, by the way, this is on page, the table's on page 196 and the book is on page 195. So these questions are, I believe, on page 196. So does your new line represent a proportional or a non-proportional relationship? Well, if we look at our new line here, this line would not be proportional because we're not going through the origin. So we're going to say, no, it doesn't pass through the origin. Okay, so it says to complete the table to show we already did that, and we are still going up at a constant rate of 4. Our rate stayed the same. How does this translation affect unit rate? Well, let's look at it. So we did move, it's like we took our entire line here and moved it, just slid it up there, right? So does it affect our unit rate at all? Well, we're still going up at the same rate, so I'm going to say it doesn't. It doesn't affect our unit rate. Okay, and then I'm not actually going to do this part here where it's asking us to write an equation because that's something we're going to talk about tomorrow. So you guys don't have to answer that part there.